So I'm going to talk about brains. Thus far, this has been an awesome day for me. I'm a professor at New York Chiropractic College. I teach clinical neurosciences. And I am talking about the thing that uses the technology, so I thought it was worth the discussion. Why should we care? Well, actually, understanding how the brain works might help you choose better which technology you want to use. And obviously, there's a variety of students that we have in our classrooms, and we know that they are much different than the students that used to be around, their thought processes, expectations, etc. So I think, obviously, to say that technology isn't appropriate would probably be a grave mistake, but which would be important. We have students, that are active learners, that are engaged, but, there's also that other population that we have to deal with, and, that's always a concern. I'm going to be talking about the brain and learning and memory, neuroplasticity in the brain, neuropeptides, neurotransmitters of the brain, dopamine-saturated brains, and why happy brains learn better. Technology in the brain, ultimately. I love brains, I do. But I promise not to have a neuro party up here all by myself while we're doing this. But in a sense, it makes you a little bit smarter about what we're actually applying here. Much of this you probably know, and maybe I'm going to give you a neural basis for the things that are intuitive or things that you've actually learned before. But learning and memory are two actual different things. So if we engage a student in technology that helps them to memorize, which is actually good, they can recall certain things. But ultimately, I think in higher education, we're looking for learning. And learning is the ability to integrate, to associate, and apply these things. And there actually occurs in different places in the brain. So what the brain is, billions and billions. I had to say that because we're in Ithaca, Carl say, don't. Yes, okay. Of neurons surrounded by glial cells, and then these cells produce neuropeptides. What does this really mean? It's a bunch of cells held together by glue in a sea of chemicals. The chemicals are produced by different events and also, most importantly, by feelings. That's the brain. There it is. All different parts. The important thing that really I want you to be aware of is, I'm going to step away for a moment. Sorry about the filming. All of this under here is what we would consider subconscious. And then everything above that is what we would consider conscious brain. Now, memory 101. Hippocampus. I always say to myself, elephants never forget, and neither do. There you go. The hippocampus is where initial memory is formed. The important thing about this, and just kind of interesting to know, is that initial memory. So I say to you, the parietal lobe is for pain. And it's easy to remember because parietal and pain both start with the letter. There you go. So initially, we've got a lot of CREB1 produced because that was kind of fun. If I say neuropeptides, neurotransmitters, endorphins, dorsal cell, and intercell, all of a sudden you get a lot of CREB2. CREB2 helps you forget. It does. And the balance between these two things is really an interesting dynamic. If we didn't have any CREB2, you would remember everything, like how many birds you saw on your way to this conference. And there's not a test on that, right? So there's a balance there. But in the classroom, this is a dynamic entity, because when we're imparting new information, we want them to have a lot of CREB1. CREB1 is directly attached to feelings. So I've said feelings twice here, and I'm talking about a very linear structure like the brain. But it is about how we engage a student. You're going to see that on every level that we talk about. And you probably know about short-term, long-term, and flashbulb memory. Short-term, it's in there for a moment. Then there's some things we don't remember at all because of too much CREB Very good, crib 2. Flashbulb is when there's an emotional association. But it's long-term memory that I think I want to really focus on. When something happens, how do you get something from short-term to long-term? If it's different, if it's exciting, like you're driving to work and all of a sudden there's this weird bird, a dodo, walks across 96B, something like that, you're going to remember that, right? But if it's just a flock of geese, maybe not. There's nothing special about them. When we talk about information in a classroom, new concepts, the things that make things go from short term, which is still in your hippocampus, which is for memory, to long term, which takes all the higher part of the brain, that conscious area, remember the happy colors, is recalling the information by thought, repeating the information verbally, different than pushing buttons, okay? Explaining the information in your own words, that's cortical integration, and ultimately this is personalization. They start to own the material. So when we're looking at different kinds of technologies, these are things that are going to make this not just valuable and fun for the moment and the information falls away, but things that they're going to stay with them, be able to utilize at a later date. When we talk about damage to a hippocampus, when that's damaged, a person can't make new memories, not in the way that we're talking about. We're actually talking about declarative memory when we're talking about the hippocampal memory and going into the brain. When you damage the hippocampus, you can't make new ones of those, but you can do something else. There's a different kind of memory. It's called implicit. And this goes through that low area that I showed you on the brain chart. This goes through the cerebellum. Now, this is like riding a bicycle. They say, well, you ride a bicycle. If you haven't ridden one in 35 years, you can still ride a bicycle. You don't need your hippocampus for this. This is a different kind of thing. So what kind of tasks do you want your students to learn? If you want your students to learn something more like a motor skill, sign language as an example, or any task that is relevant to everybody, because we're obviously all teaching different things. But you're going to have to take this information, apply it as best for you. What we want to do is create an engram. I'll show you what an engram is. Okay, I told you I wasn't going to have a neuro party. Okay, Simon says, do this. Okay, you actually have an engram, a pattern in your cerebellum that says this is the right way to do it. I'll show you. Take your hands apart. Put them back together, but the other thumb on top. No engram. You feel the difference? All right, how do you make one of these? You just have to repeat and repeat and repeat and do. So the cerebellum is this down here. Very special and very important in learning and memory, because ultimately it does get associated to the cortex. But it's like we're going to get a memory in through the hippocampus, or we can get one in through the cerebellum. Two different ways. And what if you can do both? It's more powerful, more prominent, and it makes a bigger neural imprint. So that takes me to another topic that I want to touch on, and this is neuroplasticity. Is that a term that's familiar to you? Not really? Okay, I'm used to talking to docs. So this is so cool for me, because you're like little kids to me. It's like cool, you know. So, okay, neuroplasticity is the brain to be able to form new connections. Now, this is an important concept in education, because we're always talking about creating connections in the brain. We consider them intellectual, getting a person to associate new learning skills. But the thing that's important here is that you had an experience where you put your hands together and you said, okay, I learned, I have this pattern. You can learn how to make the other thumb feel normal on top. In the same way, if you want to comb your hair a different way. First, it feels funny, doesn't it? That's because there's no engram for the way you comb your hair, believe it or not. Riding a bike, combing your hair, it's all in your brain. It's an amazing thing. So the thing that I want you to be aware of is that as a person learns, they create these pathways. We call it the law of facilitation. So it's just like water running down a mountain. The more frequently it goes in a certain way, the more likely it's going to go that way. Why? Because you get any kind of resistance out of the way. So the water starts pushing away rocks and you get kind of a groove, right? A neural kind of a groove is the same thing, except it's electrical in this sense. The important point is that once you build these networks, they don't go away. So if you learn something wrong, you learn something incorrectly, you basically will never lose that. Now, when you have to correct it, what happens is, the research shows that that old pathway exists. You're going to use part of that and you're going to branch off. Now, if you can imagine someone who has a stutter as a child, they go to speech therapy and have an opportunity to rehab, etc. At a given point, they no longer have the stutter. But what, even as an adult, can happen if they get a little bit tired or fatigued? What happens? Can pop back out again, right? Same thing. So these neural networks actually exist. So it's very, very important that students do learn things properly first. And that, to a large degree, is not our responsibility. It's their responsibility to practice or to structure their own personal learning time to meet what we do in a classroom. And if they understand this, they might be more likely to be less sloppy. Wouldn't that be nice? Yes, I agree. Okay. All right, so something about this. So we're talking about learning, that the ability to associate memory. And this association creates these neuroplastic changes actually in the brain, structural changes in the brain. The downside is it'll adapt to anything. So bad habits too. And that becomes normal, just like this. Which thumb is on top is an absolutely arbitrary thing. It doesn't mean anything if you're left or right thumb. Why is it? Well, that's the way we do it, yes? So it's very important, too, that with certain behaviors, especially if someone likes that behavior, those things can be addictive. I'm going to talk about that in a couple minutes. It seems like a very strong word, but on a neurochemical level, it actually is. You can get addicted to being lazy. In the same way you can get addicted to learning, if we can build the right receptors. And I'll show you how. For a moment, multitasking. So our students are crazy multitaskers. And in a sense, there's some desensitization of the brain. You can see that in students if, let's say, you take technology completely out of a classroom and you just talk. A lot of them just can't stay engaged. There's just not enough to do. Take a look at commercials and editing or TV shows and movies, how fast the scenes change now compared to older movies. It is amazing, and it's deliberately involved in keeping attention. Commercials very often, 2 seconds per frame. So, my God, that's crazy. Now, along those lines, just because they do doesn't mean that they should. And just because we do it doesn't mean it's good. The research that's out there, and without spending a lot of time on this, is that when a person is listening, they engage primary parts of the brain in listening. And when they are seeing or giving something visual, they engage the primary parts of the brains that are visual. When they're asked to do both at the same time, overall brain function diminishes. So as they multitask, just because they can, and most of that is occurring at a subcortical level, not subconscious, different thing, but their whole brain isn't engaged. It's a motor skill, isn't it? It's a lot of cerebellar stuff going on. They're not activating the cortex. So as busy as they are, the cortical activation, that's where learning takes place, that's where association takes place, is going down. Interesting stuff. Check this out. Zoned, okay? Just zoned out, right? You try to get someone who's been texting for 10 minutes to get you to make a little eye contact or engage them in conversation. You notice that eye contact is kind of an issue sometimes with students? At all? No? Yes, no? Yes? Yes. Okay, yeah, it's a phenomenon. And then it becomes a social thing, and then we emotionally get involved because we take it personally. Right? Yeah. But we actually shouldn't, and actually they shouldn't be doing that. There isn't any literature that shows that's good for you. Now there's something else that can happen. The students can appear absolutely engaged, but they are neurologically checked out. They can be looking looking right at you. Now, here's something that you can take right back to your classrooms that is extremely important. You can be looking at a person, looking at a person, looking right at them, and talking to them, and they're looking at you. They may even be writing. You ask them a question, and they don't know what you said. Right? Why are you laughing? What year are you in? Oh, yes. So yeah, there you go. I knew that's why he was laughing. So it's an amazing thing. Here's the other thing that as educators, we've got a bunch of people looking at our face, and they're looking up, and you're giving them important information, and they're not necessarily writing it down. They're not flagging it. The research says that students exhibit failure to extract important information from the ongoing bombardment of the sensory information. So they get to a point where they can manage. By the way, I have handouts that have references and resources for you in the back by the door. So anything that I have here, you have access to. So they've adapted to this wall of sound through the lower levels of the brain, and they can handle all this stuff going on. But when something's important, they can't pick it up. That means when we're talking, when we're lecturing, you have to be very careful to flag what's important for them. Try it once or twice and watch what happens. It's like you've pulled them from Wonderland. It's like, oh, it used to be that you lectured and you'd say, doesn't that sound like a test question? And they all write it down, right? Today they go, it's an amazing thing. So that's really something for us as educators to clue into and maybe facilitate our learning a little bit in the classroom. Literature says if you learn while multitasking, that learning is less flexible and more specialized, so you cannot retrieve the information as easily. What that picture says to me is, that's what you say, I'm going to spit that back. So there's less cortical integration, less higher integration in the brain, and more so in the hippocampal learning centers. So what we really want to do, instead of just spit back, obviously, is to engage. So any kind of technology that causes that. By the way, we all know we don't necessarily need technology. What we're doing is trying to, in a sense, keep up with what they're used to, how they're used to being served, right? So it's important to keep that in mind, that they've got to be integrating the material. Another cool thing about brain for educators, research has demonstrated significant amounts of neural learning occur just prior to sleep and into sleep. Your brain actually does and repeats what you did just before sleep. I tell my students, study the hardest thing that you know, the thing that you're having the most difficulty with, study right before sleep. Neural networks actually form during the course of sleep, and I'm so sorry. The student will actually experience a better learning in the morning, and some of you may actually have had that experience. So you tell them that doesn't mean sleep on your book. It means you have to read your iPad or whatever it is you've got right before sleep. The last little topic I just want to throw on in here is about neuropeptides and neurotransmitters. And we're going to, again, keep this just user-friendly. There's this mind-body connection thing that's on out there, and actually it has a lot to do with a lot of things, and that's another lecture for another time. But the point really is, to a very large degree, on a neural level and a chemical level in the brain and the rest of the body, what a person believes they can achieve. And that also means that if we interact with them in the most positive way possible, if the feedback they're getting from whatever technology you're using has a supportive element to it, it's going to be better for them ultimately than one that doesn't. Okay. The important thing here, and I'm going to tie this back to what I've kind of said all along, is that an emotional engagement in the learning process has a bigger neural impact, better. You already know that, yes? Now, the important thing here around this is that whether that's positive or that's negative, it's going to make an impact on them on a chemical level. So it's kind of important to keep things obviously very, very positive. when a person is in a classroom or an environment that's under constant stress, the literature says that you can decrease learning and actually long-term create degradation of actual brain tissue over time. So it's extremely important that we consider who we are in the classroom. So the technology is something that we use as a tool, but is not necessarily something that is doing the teaching for us. Presence and the personality and the nature and the environment in the classroom has a huge role in the learning experience. You've heard about dopamine, yes? That's the big thing. Okay, good. Okay, happy brains, they love it, but it's addictive. And that's one of the reasons that short-term reward system is so important with our students today. One of the reasons that use of technology can be so effective, because we buy into something that they've already established. Neuroplasticity set it up. We're just going to jump right on in that bandwagon and make it work for us. But again, these things this whole thing about reward is really interesting. I've read a lot of literature about this, and some teachers like to throw candy and things like that. One of the things that's really important in this is that the reward has to match the value system of the recipient. And when you have a large classroom, you have more than one person there may be more than one. So I want to just keep in mind for you around reward. Obviously in technology, lots of the times this is built in. But for us, sometimes it's remembering a student's name, the eye contact, the attention of compliment, and those things go a very long way. Because we are still, even with technology, still organic systems that are built and wired for certain things that to a large degree, it may be, and I'm just giving an opinion here at this point, may be that what people are missing, they're trying to replace with the gadgets, etc. I think eye contact goes a long way. So the big picture in what we want to look at here is what kind of learning do you want to desire? Is it implicit? Is it declarative? Are you getting the repetition or the integration, etc., from the technology that you have? Teaching style and multitasking, all those things have to be part of what you look at. I know that I only have a minute left, but in case there are questions, because this is the last one of the day, and your brains must be fried. I'll give you a moment to any questions I can answer for you. Yes?
Generally, what learning strategies do you find are best for sort of implicit learning set of elements? Learning strategies for implicit learning have to do with moving. Yeah, and understanding why you're moving. If you activate the musculoskeletal system in the act of learning certain things, that will activate the implicit learning system. Actually, as more directly than almost anything else. Anything else? Yes, sir.
You had a slide on seeing and listening together and how that might be ineffective.
Yes.
Could you expand on that? Because a lot of e-learning is very engaging because it has audio and video components to it.
Yes, I think the studies that are done are not necessarily in the setting of learning. Those studies were kind of if I show you a movie and then I talk to you about something else, the brain diminishes. So I don't think in those studies they were talking about things that are complementary. So the reason I brought them in is because lots of times students will study, they've got their iPod on, they're texting, and etc. Now you've got things that are not complementary, and that's what will diminish the brain activity. Yes, sir?
There's a big debate in my school whether students should be able to use music as white noise while they work alone, such as writing or doing research. And we're on both sides as far as the faculty as whether that should be allowed. I was wondering if you could give some insight as to...
Well, yes, I can. It depends on where they actually process the music. And when we hear things, different cultures process things differently. In Japanese culture, sounds of nature is processed in the area of the brain that we process music. Over here, we process sounds of nature as where we process noise.
So I'm going to say that that's going to be very, very individual. But if a student is made aware that here's some separation for you, just because it feels good doesn't mean it's working for you. So if you're looking for white noise, maybe you should go with white noise instead of music, because now you're talking about words coming at you, rhythm, all these things, textures, volume. These are all engaging different areas of the brain, and the more it does, the less higher function you're going to get. You're welcome. Anybody else? Thank you very. Oh, yes, sir.
Could you speak just briefly about the glial cells and their function in terms of nurturing the nerves, the dendrites, and acting as a vacuum that erases essentially or clears out in the first 48 hours, usually during sleep? If that's correct, first of all, is that statement correct? And can you elaborate just a little bit more on their function?
No, I haven't read anything. I'm not aware of kind of what you said.
Okay.
Yeah, the glial cells basically are just a framework. It's like Jell-O, in a sense, and the brain is kind of like Jell-O, and the cells are actually being held in place by this Jell-O, and that's their real purpose. It's a structural thing more than it is a neurocentric type of thing. Yes.
Right brain learners and left brain learners.
Right and left brain learners, yes.
Yeah, so is there any subtle scientific evidence that both right brain learners are different from left brain learners and they're different?
Yeah, they just learn a little bit differently, but we are used to, in this society, left brain learning. So it's didactic. Here are the lists, here are the things you need to memorize. The gentleman about 2 lectures before me said something about a picture meaning 1,000 words. I showed you a couple of pictures, you get it. So that's right brain learning. And actually, I think we all do very well with that, because that is our intuitive side. You show a picture and now you no longer have to memorize a lot of details. I think that's fostered less, but there are some people naturally that way and naturally the other. I don't think one is better. They both communicate through the corpus callosum in the brain, so ultimately it should balance out. And I think that's my time. So, thank you very much.